The ship digital shadow operates as a one-way monitoring system, ingesting real-world sensor data without providing feedback to the physical vessel. So it just shows everything on the screen, but it doesn't give any feedback. Its architecture features a dedicated sensor fusion module that processes these that processes these live data streams using advanced estimation techniques such as extended Kalman filter or unscented Kalman filter or particle filters. And the aim is to maintain a continuously updated digital representation. This is a sensor-driven approach, and it proves particularly valuable for condition monitoring, fault detection, and operational analysis, where active control is neither required nor desired. A practical implementation of this digital shadow concept is, you can see this in the modern ECDIS systems, the electronic chart display and information systems, where navigational sensors like GPS, gyro compasses, AIS, they feed real-time positional and environmental data into the digital representation, but this is without any bidirectional control. So it only mirrors what is being done in the ship, but you just observe it. You don't interfere with it and return any feedback back to the ship. Okay, so levels, again, 2 levels here. The first level is only for passive performance monitoring. The second level is supervisory remote control. I'll explain these. So in passive performance monitoring, there is only one-way data flow for performance assessment. No control loop is shown. In the second level, human operator provides desired states, and sensor data helps the controller correct deviations, but human still remains in the loop. So in digital twin, we will see in a couple of minutes, we are generally outside the loop, but here we are still inside the loop. Humans are still inside the loop. Level 1 is at the left-hand side. Again, there's a human user, you see. The human user sends the actuator commands to the sensors inside the ship. So, sorry, to the physical ship. You see the arrow sticks to the physical ship. This physical ship is inside an environment, and there are some sensors in the physical ship. Those sensors reflect what is being, this data is collected in the sensor fusion filters because there are lots of data coming from sensors. They need to be fused. And after fusion, sensor fusion, they are visualized for the human user to see what is actually happening. In the second but there's also a second level, which involves here in this, you can see it at the right-hand side, it involves a control loop. In this level, a human operator inputs a desired state for the ship into a controller. You see SD here. The controller then sends the commands to the ship's machinery, like the propeller or the rudder. Sensors then capture, you see the sensor here inside the physical ship. Sensors then capture the ship's response to these commands and its environment. This data is filtered and sent back to the controller. You see there's also an arrow here going back to the controller because this is also another loop inside. So this is, yes, this is a digital shadow, but there's also a controller loop inside here. The controller uses this information to correct any deviation from the desired course. The process data is also shown, you see the arrow here, to the human operator who can take further action if necessary. So things start getting more complex, but this generally, digital shadow is only for passive performance monitoring, or the maximum is supervisory remote control. You still remotely control it, but the computer gives provides some supervision for the human operator.